Hello and welcome to Software Architecture course. Today we will study an important quality attribute called interoperability. So just like other quality attributes, we will study interoperability, its tactics, and various design checklists that as an architect we have to consider. What is interoperability? Basically, interoperability means that two systems are able to interact with each other and exchange the data information. So basically they exchange the data or information through well-defined interface. Now that's not enough. One is of course transferring data, which is syntactic. Another is interpretation of data, which is semantic. So when we say that two systems are interoperable, it means that I'm able to not only transfer the data without any problem, but also the systems are able to understand each other's data and of course process it. This information exchange can be direct or it could be indirect. Information exchange happens through, as I said earlier, through an interface. This interface is actually what is called beyond an API. Now, beyond API means that when you are wearing the hat of a programmer, then and you are using a programming language to develop a system, then you already know that in most of these object-oriented systems, it is basically the concept of classes and interfaces are very common. So of course, when you're talking about interoperable systems and we are talking about interface and we are saying interface in the context of interoperability, it is not the interface that we popularly know in the context of OOP. It is more than that. So the additional part is that beyond the API, there has to be a set of assumptions which have to be very clearly made that one can safely make about the entity that is exposing the API. So when there is an entity or a system which is exposing an API, and when there is another system which is trying to consume the services through this API, then there has to be a set of assumptions that the consuming service make about the entity which is or about the system that is exposing the API. So these assumptions should be safe and should always work. For example, you want to integrate with the Google Maps. So Google Map is going to expose an API, and then your system is going to be integrated with Google. And of course, there could be assumptions. There could be various assumptions. For example, it will always give you the coordinates in certain format. It will then, for example, if your application is location aware, then essentially when you basically send a request to Google for the current coordinate, the Google somehow understands where the current application is located and then accordingly sets the coordinates, or maybe it can provide some additional data. So these are the assumptions that you as an application developer you are going to make about Google Maps, and those assumptions are typically documented. So why you need to interoperate? Why it is important to interoperate? Basically, the team who has built Google Maps, so that team have no clue who all are going to use the service, and they cannot even predict or anticipate, because once it is up in the air, when it is up and published in the cloud, then anybody can use it. So therefore, the first assumption is that the map developers must not know who is going to use Google Maps. Now, when you are basically building, so that's from the service provider perspective. What about the service consumer perspective? That is you. So you want to construct a capability from various systems, not just Google Maps. So suppose that you want to build a system which is a traffic sensing system that can receive a stream of data from different vehicles, and you need to process the raw data, then you need to fuse the data from other different sources, and you need to basically decide the traffic congestion, and then that data needs to be overlaid with the Google Map. For example, you want to basically take Google Map and get the road view and then basically overlay your information on that road view, showing which roads are congested, which roads are not congested. So only Google Map is not sufficient. Basically, there has to be other players who are also going to basically be involved. So therefore, Google Map must interoperate with other systems. Your system also must interoperate with not just Google Map, but from other systems. So this is what is meant by interoperability. So let's look at basically a particular scenario. It's a very typical format that we had been using so far for all other quality attributes. This is no different. So let's first look at who is going to be using or be impacted by interoperability. Basically, it is a system who is initiating the request. that system expects interoperability. For example, a vehicle information system that you are going to build. Then what is basically the stimulus? The stimulus is, in this case, or an event, it is basically a request to exchange information. For example, in this case, it is sending its current location. The vehicle information system sends a current location. Then if the whole thing is interoperable, then it is basically the entire system typically which is impacted. So for example, there has to be a traffic monitoring system which must be discovered prior to runtime. So the vehicle information system must know the traffic monitoring system even before runtime. And then, so therefore, the impacted system must be already discovered either at runtime or prior to runtime. In this particular example, this needs to be discovered prior to runtime. But in some other cases, it may so happen that a system need to be discoverable at runtime, not during the compile time. Now, what is the response? So when there is a request to exchange information, in this case sending the current location, then so essentially the action could be the request is accepted, information is exchanged, or the request is rejected and appropriate entities are notified. And in any case, whether it is accepted or rejected, it needs to be logged by one or more systems. Very important, because there are many systems involved here. So for example, in this case, when the request is accepted, so what happens is this vehicle information system combines the location information with other detail, overlays with the Google map, and then broadcasts this information. So how you can measure whether the system is interoperable? Basically, the metrics could be that the percentage information that has been exchanged successfully, that could be one measure. Percentage information that has been rejected successfully, that could be another measure. So this vehicle information system is 99.9% interoperable, because here this vehicle information system is able to include this overlay and all this stuff 99.9% of the time, but maybe for 0.01% of the time it is not able to overlay. So it's mostly interoperable. So here the notion of interface is very important. It could be as simple as A calling B, or it could be typically A and B are exchanging information implicitly without any direct communication. That could be a complex one. So here there is a case study that because of lack of interoperability, some problems happened. So it was about Operation Desert Storm, which was the war scenario, where basically the anti-missile system failed to exchange information or intercept an incoming ballistic rocket. So what happened was that the system required to periodic restart in order to really recalibrate its position, but the system was not restarted. That anti-missile system was not restarted. Therefore, the information wasn't correctly captured due to accumulation of error, and as a result, it could not really intercept an incoming ballistic rocket data, and therefore that particular operation was a failure. It actually failed. So this assumption that it needs to be restarted, otherwise there will be an error accumulation, these are the assumptions that I was talking about at the beginning, that there has to be some safe assumptions. If these assumptions are not made correctly, in this case this is not a safe assumption, that anytime this anti-missile system is up, it can exchange information. This is not a safe assumption, because the underlying expectation is that this system need to be rebooted multiple times. Therefore this assumption was not safe. So yes, so like what I said is that this is about safety of the assumption. Question is that, is it really safe to assume that the API of anti-missile system to give information about gradual degradation? Now it is not safe. On the contrary, if you have to write a piece of software which is going to be integrated or interoperated with the anti-missile system, for you the safe assumption should be that the API of anti-missile system does not always give the information. You should make that assumption and then write your program accordingly. There are many such examples. Suppose you want to integrate with Amazon's different services. It is not safe to assume that anytime you make a request, you will get the most up-to-date response. So that's not a safe assumption. On the contrary, the safe assumption should be that anytime you make a request, there is always a chance that you will actually get a response which is kind of a stale. So you may have to request multiple times. That's a safe assumption. So let's talk about interoperability now in more detail and various tactics. One is basically locate tactics, another is managing tactics. So we will look into these tactics in more detail. Locate means that it's service discovery, identifying the service through a known directory service. Here the service implies that there are a set of capabilities that are available through an interface. So essentially, when I say I am offering a service, it means that I am already offering a set of capabilities and I have already defined an interface. Now this locate or location of services or discovery of services can be done by name, by location, or by any other attributes. So when you are talking about interoperability and talking about interoperability tactics, specifically locate service, you need to decide how you want to expose this interface. Is it by name, is it by location, or is it by some other attributes? Let's look at some of the tactics. Managing the interface. So managing the interface consists of two parts. One is orchestration and there is tailoring. Let's look at orchestration. Orchestration is important when you are building a complex workflow consisting of different components, and these components, some of these components are basically external systems, and they are interoperable, and your system is going to interact with those external systems to basically get certain services. Example is the vehicle information system, where Google Map is an external system. Traffic monitoring system is another external system. So when you have to think about orchestration, in such a case, of course, you need to think of orchestration because there are multiple parties involved and there is a workflow. The important tactic is that you need to coordinate and manage a sequence of services that need to be defined first, and then you need to be coordinated. For example, workflow engines that contain scripts of interaction. Then how do you do it? Techniques are BPEL language for complex orchestration. BPEL is a popular language that's it's called business process execution language that could be used for complex orchestration, and then BPEL engines, typically workflow engines, that can understand this script and then can execute it. Then design patterns like mediated design pattern can be used for simple orchestration. Tailor the interface. Now this tailoring of interface is another tactics where if you want, you can possibly have a capability to add or remove additional features from an interface. Example is that suppose you are exposing certain service and you want that service to be used only by authorized users, but at the same time you also do not want to drive or antagonize potential users. So you want a more control that if a user is not registered or trusted, that user can still try and test your interface, your service, and if that person likes it, then that person can eventually become a member. So what you can do is that you can possibly hide a set of functionality for untrusted users and provide some basic functionality, and as soon as the user becomes trusted, then you enable those functionalities. This is basically called tailoring the interface. One can use a decorator pattern for adding additional functionality. Now in interoperable systems, typically at least in today's world, the interaction happens over the web. Cloud-based systems, software as a service kind of features. There are various services that exist today, and interaction happens primarily through REST or any other kind of protocols. So these APIs, those interfaces, basically behind the scene interact with the server through some kind of intelligent protocol. So let's look at one of them, which is the most popular today. It's called REST protocol. REST means representational state transfer protocol. It's basically an architectural pattern where the services are described using an uniform interface. RESTful services are typically used as a hypermedia source. Basically, REST is important part is REST is stateless. Every request is basically starts and ends. I mean, the next request has got no knowledge about the previous request. Very simple. It basically looks like a HTTP request, and there are 4 basic operations that you can perform: post, get, put, and delete, and they basically behave like a CRUD operation. Post means create a resource, get means retrieve a resource, put means update a resource, and delete means delete a resource. Example is that Google Suggest. You can use Google Suggest, and Google Suggest is essentially when you type certain queries in the text box which is there in Google search page. Then when you type certain fields, you will find that it comes up with a set of suggestions. So this is achieved through REST protocol. Example is given here. You can try this: http suggestqueries.google.com, and you could basically say /complete/search $output equal to toolbar and HL equal to English and query equal to whatever query you want to put, and you will see the result. Similarly, Yahoo Search also provides a similar REST kind of protocol. In comparison to REST, there are other protocols like SOAP or WSDL. REST is most popular today. SOAP was earlier proposed. SOAP is more heavyweight, REST is more lightweight, and today REST is being accepted by the community. Essentially, for software for the service-oriented architecture, people have claimed that SOAP and WSDL is too complex, and people wanted agility. Therefore, they actually want a REST as opposed to SOAP. Let's look at comparative study of SOAP versus REST. So the purpose essentially is the same: message exchange and perform operations, access, manipulate different hypermedia systems. But the origin of SOAP is more like RPC, which is more rich protocol. REST is more based on WWW or HTTP protocol. Functionality, therefore, in SOAP is quite rich. REST is minimal, just 4 operations. Interaction is more of orchestration based, event based. It is just request and response in case of REST. Focus is more process oriented here. The REST here is data oriented. Process should be there as a part of the application. It shouldn't be the part of the protocol. The methods and operations, again, it varies. Here it is all fixed. Reuse means it is basically centrally governed. Therefore, however, in REST there is no governance at all. Therefore, it is ease of use actually. Only on the client side it is there. However, for the SOAP, it can be maintained in both client as well as server. Format is SOAP is input, and output is also SOAP. Now here it is URI is an input plus some additional REST queries that is input, and what you guess is POX is the out. Transport is here. For SOAP, it is transport independent, so it can reside on any kind of transfer. It can reside on top of any of the transport protocol, including HTTP. So that makes it more flexible for SOAP. However, for REST, it is very strict. It has to be HTTP only. Security is web services security or WS security. However, REST again depends on HTTP authentication as well as SSL. So it is basically HTTPS. So as you can see, REST is primarily riding on top of HTTP, simple, quite fixed. Therefore, it becomes much easier to use, and that's the reason why it has become more agile. Let's look at different design checklists. Allocation of responsibilities. So as you know earlier, for design checklists for other abilities or other quality of service, let's look at what are the design checklists that as a designer you need to have and check during architecture and design. One is allocation of responsibilities. First, check which system features need to interoperate. This needs to be done during the requirement as well as architecture time. For each of these features, ensure that the designers implement accepting, rejecting of request, logging of request, notification mechanism, and exchange of information. Then decide on the coordination model. Coordination should ensure that the performance SLAs must be met. Plan for handling the volume of request. Plan for timeliness to respond and send the request. Then check for currency of the messages that are sent. The coordination model should be able to handle different jitters in the message arrival time. This is very important because the system that we are going to interact with can always have a failure. Therefore, your system must be able to handle those failures. The message might be delayed in arriving. Let's look at some more design checklists. Data model. What data need to be exchanged among the inter-operating system? That needs to be decided. This one, you also have to identify which data cannot be exchanged due to confidentiality measures. So this is very important, that which data needs to be interoperated, which data need not be interoperated, that needs to be identified. Identification of architectural components. The components that are going to interoperate should be available and secure and meet performance SLAs. So in fact, the components that will be responsible for such things, you have to make additional care. You need to look at those components more specifically and check that yes, they should be available all the time. So apply availability tactics on those architectural components. Apply security tactics on those architectural components. Apply performance tactics on those architectural components. Very important. What about resource management? Ensure that the system resources are not exhausted. That's important when you are going to offer a service. When you're going to offer a service, you have no idea who are the people who are going to use it. Therefore, make sure that the system resources are not exhausted, and make sure that your system is safe from denial of service attack. You need to consider the communication load. So you need to think that you obviously make sure that the communication becomes minimal. So when the resources are to be shared across obviously different users, plan for different arbitration policies. Binding time is important. Essentially, when two systems need to be bound, that capability should be there. Then ensure that the proper acceptance and rejection of requests are actually built into a system, that beyond certain limit you must reject the request. Ensure the service discovery when you want to allow late binding. So essentially, when you are going to allow late binding, you must ensure that your service is discoverable. That's very important. Remember that resource management and binding time, these are important when you are going to offer a particular service. Technology choice. So consider the technology that supports interoperability, for example, web services. So while building the system, take this into account while building your system. That's all for interoperability. Thank you for listening to this lecture.